Hey everyone, how are we doing? We are back here at Stat 201. Had a fun crossover time. Huge shout out to Dr. Pittman, really doing some fun stuff. And as I always say, education should be fun, enjoyable, and accessible to everybody. So really a lot of fun. And you just gotta enjoy life. So with that, do we have anyone here who wants to do any MyPearson work? What are we working on? What do you want to do? What questions do we have? Hey Daryl, good to see you there. Let's throw you some points. Turn on a little chill music. What are you working on, Daryl? Chapter 5, data analytics. What are we working on?
Oh man, I got like 6 hours sleep last night.
Always like, I was on email. Chapter 5, part 2. Quiz or homework? Quiz or homework? Quiz or homework? Do either or both. The basics of statistics. There's breakfast? Oh my gosh. Faculty appreciation? Ham biscuits and yogurt bars available in lunchroom. Oh man, the quiz. Okay, which questions are we gonna do on the quiz? I'm gonna go see some real good. I'm gonna go see if there's like wrapped biscuits. I might take one. Be right back. Tell me which questions. Be right back. I'm back, Daryl. Which questions are we gonna do? What should we do? The quiz, but which questions? There's a lot of questions on the quiz. Which questions should we do on the quiz?
Oh god.
Chapter 5, part 1. What on Chapter 5, part 1? You name it, we do it. What should we do on Chapter 5, part 1? You name it, we do it. Throw you some points right here. Part 1 quiz. Part 1 what? Get the notes open. The normal model. Weights of steers. Here we go. Chapter 5, part 2 quiz. Normal model with weights of steer on the quiz. Okay. So where do we need to go for these questions, Daryl? So this is different than Chapter 5, part 1. I'm going to put in the notes right here. For this question right here, where do we need to go? Do you remember the quick shortcut? Where do we need to go for these types of questions? Where do we need to go? Sometimes you want to go. Ah, yes. We go here to the app. Everybody knows your name. There we go. And you have the IQR one, which might be towards the end. And there's an IQR one. It's basically, these are the same questions. So some questions just do things different ways. And so make sure I got the office hours video and drop more questions in the chat. We do have a lot of time right here. Environmental Protection Agency, you got it. We'll do that one here next. Chapter 5, part 1. And drop your questions. You got it. Thank you, Alyssa. Alyssa, here's some more points. Thank you for being here. Okay, we're at the 5:23 mark. And with this is Stat 201, MyPearson Chapter 5 quiz. And we have use the normal model. This is steers. Okay, quiz part 2. Here we are. Now with this, when you go to the normal model right here, we can kind of figure out some answers to this, because if we think about how the curve looks, the 59th percentile would be a little bit above the where. The 59th percentile on the curve would be a little bit above where. Think logically. So we're going to do a little logic and understand what we're doing here. The 59th percentile would be a little bit above where. Think about where do you want to be on a test, in the 99th or the 1st percentile. The 59th percentile would be a little bit above where? Where would the 59th percentile be? Above 0, exactly. And the 59th percentile, if we go and view where it's at, we can type here 59. Now, very important to know, 59 in the percentile format is the area below. 59% is below this z-score. So we thought it'd be a little bit above 0 because above 0 or below 0 is 50% of the curve because that is the mean/median for the symmetric distribution. 50% of the area is below 0. 59% of the area is below a z-score of 0.228. Oddly, this can actually help us solve the answer to this one because what does a z-score of 0.228 tell us about the answer? There'll be an easier way to solve this in a second, but think if we know the z-score is 0.228, that means the answer is what? If the z-score is 0.228, that means the answer to this, because this is the z-score of the 59th percentile. Friday, almost Colin, good to see you there from Disney. Almost Friday. The answer is what? Because if that's the z-score means the answer is that many what's away or above the what. Can you finish the sentence? If this is the z-score, yeah, we can do that. Watch this. We just times it by the standard deviation, and that's its distance above the mean, and then we add it to the mean. Because remember, a z-score is how many standard deviations something is above or below the mean. So the answer is 1,144. But guess what? If we take 1127 and 75, we can just go and see the answer with 1127 and 75. There's the answer. And to one decimal place, there it is. Or round it to the nearest whole number. Oh, wrong way. Does that make sense, Daryl? Right here, we literally have the answer because we put in the mean and standard deviation, which is the context of the problem. The point on the curve remained the same, but now we're seeing the numbers of the mean and the standard deviations and seeing the 59th percentile in terms of this. We could have done the z-score, which is going to always be the same, and the z-score here was, what's going on here? Oh, because I rounded it so much. Don't round it that much. There's the z-score right there, and we can use the z-score to solve it, or either which way. Now let's look at the 93rd percentile. The 93rd percentile is on the right side of the curve, the high side, and has a z-score of almost 1.5. So when you think about this, we're basically going 1.5, not quite, standard deviations above the mean. Try to think. What's a half a standard deviation? Just round it. 1.5 standard deviations is about how much above? So you're going to the mean, and you're going up 1.5. For percentile, it's always below. Great answer, Daryl. Percentile, you always use below. You could find percentile by doing above. You'd just be doing it a little bit differently. If you enter in the number like 59th percentile, it's the area below 59, the 59 bottom percent, because 59% of people score below that. So with this, if the answer is about 1.5 standard deviations above, we could put in this number of 1.47, I think it was, times it by the 75. Yeah, and good to see you there. And then add that to the mean of this right here, and there we go. Now, I might not have carried enough decimals, but we can actually cheat and solve the last one. I'll show you how I'm doing this. Aye. And lost my train of thought. That's easy enough. I will show you how to get this. I think we might get it right. Thank you, Colin. Appreciate that. Oh, we might have missed the middle one. Once again, solve it by using the applet. Confirm your answers. We can put back in 1127 and then 75 right there. Salute. And then it is 1237. It's actually, oh, so I got the last one wrong? Oh my gosh, what am I doing? The answer for this is 101. What am I doing? What am I doing? For the last one, it's the IQR. How do you get the IQR mathematically? And you are seeing the answer to the second one on the screen right here. You can round it to no decimals here. There's a little bit of a leeway on the answers. This is the 93rd percentile. But where is the IQR? Where is the IQR? Q3 minus Q1. So let's go ahead here and enter in 0.50 and do between. Where's Q3 and Q1? Do you see Q3 and Q1 on the screen? Tell me one of them if you see one of them, and then you can find the answer using it. So we did the middle 50%, which is visually shown here, the middle 50%. So do you see Q3 or Q1 on the screen, which represents the 75th percentile? You could actually go find the 75th percentile. Yep, just those numbers. This is the 75th percentile. There's the 25th percentile, and you could just subtract them. A little bit of leeway on the questions, but does that make sense, Daryl? Like, you could just find Q1 right here, and then find Q3 and subtract the numbers. So it's like a plus or minus 1 or 2 on the questions. Is that pretty good? Is it making more sense, Daryl, how to use the applet, how to find answers? And you could always know the z-scores like I do. I'm not saying you do, but it's 0.673 if you do it via z-scores. And I'm totally entering in wrong numbers right now. This is the z-score that I knew off the top of my head. It's 4. See, I was off by 1 decimal. But I know the z-scores, so I can solve these a lot of times without using the applet because I've done them a lot of times, and the z-score doesn't change. So, yep. Yes, so you just take them and subtract them. Yep. Just take those two numbers. If you've got 1127 and you've got 75, go right here, find the middle 50% on the curve. You can now see Q1 and Q3 right there and subtract those numbers to get 101. There we go. Well, Daryl, drop a few more questions in the end. If you got questions, let me know. Alyssa had a question. We'll do that one next here. A little chill music as we get going. We'll put on this one. Here we go. Okay, Chapter 5, Part 1. 12 out of 3. Statue 1, MyPearson Chapter 5, Quiz Part 1. And this is the... Alyssa said, Environmental Protection Agency. EPA. And let's go over here to the questions. Drop more in the... Yeah. It's when you see it, you're like, really, that's it? Just find Q3, Q1? You're like, oh, yeah, yes. I think if you didn't know Q3 minus Q1 or didn't understand what the IQR is, the range of the middle 50%, now you know. Or you've been practicing this semester, I think you know it, but now you're like, I knew that, we learned that. And then you're like, I get it. Just practice. And then after a while, you're just like, it's easy. I've done this tons of times. The best tests are when you're like afraid and then you take the test and you're like, I've seen all these questions a billion times. So it's the best questions are the ones that you're like, I got this. Oh, there we go. I love this question. This is a great question. So this question right here uses the empirical rule. So what you should do when solving this question is what it out. What it out. What are you going to do for this question? You're going to what it out. The reference. Hey, Aaron, good to see you there. Drop some questions in the chat. We'll throw you some points. What are you going to do when you get to this question? You're going to what? I'm going to draw it out. Giovanni, good to see you there. If I mispronounce anyone's name, please let me know. Partially blind. Okay. So we need to take our pen and go right here and draw the normal curve. Normally distributed with a mean and standard deviation respectively. That's the mean, that's the standard deviation. We'll put those values in respective to what they are. The numbers are 24. I'm going to write 25 right here for sake of brevity, and 6. I'm just not carrying decimals. It makes the math easier. We're going to see a sketch of what we should see coming up right here. And we're going to put at the center of the curve 25 because that's where the mean goes. And then we go up and down. You know what I realized? I've never seen Mean Girls. Should I go watch Mean Girls? I need to see The Batman, because I do love The Batman, and The Nightwing. But I've never seen Mean Girls. It's like a classic film now. It's like, how did you not? It just escapes you. I know, everyone talks about it. I think, I'll tell my wife we should watch it. Oh, there's a new one? What are they doing? What are they doing? Why are we here? Okay. So you notice right here we have the mean right there. And then we have the standard deviation. Standard deviation is the units by which we go up, the spread of the curve. And then we go right here, we go 0, 1, 2, 3, -1, -2, -3. And then we go on the curve and we do 68% of things are between 1 standard deviation, 95% of observation plus or minus 2 standard deviations, 99.7 are within plus or minus 3. Here's the graphic we should see with not all the decimals carried, but we're going to go back here and find that graphic and then use it. Once again, good practice. And if you notice, the only one with the correct standard deviations looks to be this one. This one has too big. This one, I'm between two. I'm between this one. What's wrong? 68, 95, 99.7. Okay, this one's too big. This is too big a standard deviation. This is too small. That's too big. This is just right. It needs to be a standard deviation of basically 6. 24 minus 6 is 18, 12, and 6. Does that make sense right here, how to get the first answer? We're going to take a picture of this and then use it from then on to draw some normal curve stuff, and they've already given us the empirical rule numbers, which we'll use to solve the question. So that is going to be our answer. Make sure to choose the right one with the correct mean and correct standard deviation. Now it wants the middle 68%. I just want one number in the chat. The middle 68% is found within plus or minus how many standard deviations? I just want one number in the chat. The middle 68% is found within plus or minus how many standard deviations? Just review question right here. The middle 68% is found within plus or minus how many standard deviations? The middle 68%. It's a musical. The middle 68% is found within plus or minus how many standard deviations? This is a standard deviation. This is the middle 68%. That is minus 1 standard deviation. The middle 68% is found within plus or minus how many standard deviations on the curve? The middle 68% is found within plus or minus what? Plus or minus how many standard deviations? The middle 68%. Don't worry. Take a guess. Don't worry if you're wrong. We're going to throw you points. We're going to throw you big points. The middle 68% is found within plus or minus. Any guess. Any guess. No matter what your guess is, there's points. We'll do that one next. You got Daryl. Any guess? Oh my, I'm literally leaned on the button by accident. I had my finger over the button. Well, that's an error, but it's a nice error. I was like, what are you doing, Mubot? And I was like, oh, I'm just lightly pressing the button endlessly. So, well, that was interesting. Mubot, you can stop. Well, we'll remember this. Hopefully he stops in a moment. Middle 68% is found within plus or minus 1 standard deviation. I do not know how many times I hit that button. All right, that was like 8,000 points. Yeah, you're right, Mubot. So many Mubucks given out. The middle 68% is found within plus or minus 1 standard deviation on the curve. So we go right here and we simply go plus or minus 1 standard deviation on the curve. I was like, what is he doing? I had my finger over the button. Well, I said there'd be big points. I was right. And so plus or minus 1 standard deviation. The percent of autos that get more than 30.95 are above a z-score of what? I want you to z-score this. The percent of autos that get above 39.5 are above a z-score of what? The percent of autos that go above 39.5 are above a z-score of what? That would be above a z-score of what? Which the answer to the question is this. That's the answer. So we're trying to find. So the percent of autos that get above 39.5, 30.95. Well, we need to find this. So we're going to use this answer. It is 16%. Great job, Alyssa. And at these points, you're like, Brian, it's only 500 points. Well, okay. And you can check your answer if you've done the drawing correctly by making sure everything adds up to 100% if you kind of ride across the curve right there. So we've done it correctly. It is 16%. Great work. Excellent job. Between 30.95 and 37.13. Remember, drawing it out makes it way easier. And now we're talking between these two areas right here. The correct answer we're looking for is between here and here. This is the correct answer. Always draw it. And I think it was those. Yeah, it was those. And explain what our challenge should be. Yeah, Sydney, I can do that here. We got another question, then we'll do that one. And so think about this. You have to subtract this area out of the total 16 we just found. We just found 16%. So we don't want this area. We're going to subtract off this area. How much is this area we're subtracting off to get the answer in the middle? We're trying to get the answer in the middle. So how much are we subtracting off? And you can use the 95 to help you out because we're not doing 95. We're doing the outer percentage. Close. Very close. This is 2.5. And you can tell because if you go across this, it adds up to 100. So that is 2.5. So what is the answer? You basically have it, Alyssa. If you use the same idea but with the right number, you got this. We'll points in the chat. Correct. That is the right answer. So it'll be 13.5 between those numbers. And next, we say the worst 2.5% of cars. Well, we actually already have this drawn on the screen. The worst 2.5% of cars would be on the left or the right side of the curve. We're talking about how well they're doing right here, that you want this number to be higher. So the worst 2.5% of cars would be on the left or the right side. Higher number is better here. So the worst would be on the what side of the car? What side of this curve? The worst would be on the left or the right side. Where would it be? The worst. The worst would be where? Where would the worst be? Left or the right side? You want high numbers. So the worst would be down here somewhere. That's the, good answers, it'll be on the left side. This is the low side. We want high numbers. So with this, where's the bottom 2.5%? It's below where? The bottom 2.5% is below where? The bottom 2.5% is below where on the curve? Where would it be below? We've got it drawn out using the 95 rule. I'll remove some stuff to make it easier to see. Well, 95 means 95% of the area is contained within here. If 95 is contained within here, that means the upper 2.5% is here. The top 2.5%, the best, and the worst is on the other side. So what's the answer to what is the measurement or the observation for the cars that are in the bottom 2.5%? What is their measurement? Remember, we're talking the bad side, the low side right here. So what would be the percentage or the amount of it? The amount, not the percentage. What do the cars have? Don't worry, just take guesses. The more you practice, the better you get. I'll answer in just a moment. Just take a guess. So we want the value of the car and what its value is. Right there. 12.41. So the worst get less than 12.41. It's the worst cars, because this is miles per gallon. So the cars that are not getting good miles per gallon get less than 12.41. This is the lowest. Does that make sense, Alyssa? Let me know. This is the lowest right here. I'll highlight just it. The lowest 2.5% of cars get less than 12.41 miles per gallon. The lowest cars, this is their miles per gallon, and this is the lowest 2.5% of cars. Does that make sense visually? Tell me how you're doing on that. That's the lowest 2.5% of cars right there. They get less than 12.41 miles per gallon, which is pretty low. And we should get 100, unless I've made a mistake right here. Check answer. 100! You got it. Nice job, Alyssa. Congratulations. Okay, let's do another question. Daryl had one. Chapter 5, Part 2. And then we're going to do a little data analytics. If you have questions, just drop them in the chat because we do as many questions as we can get to. We do as thorough of analysis. We work through with everybody. So just hop into any of these office hours and say, explain this question to me. And if you don't get it, tell me you don't get it. Answer questions. Don't worry about getting it wrong. We're just here for practice. The only way you get better is just practice. Traffic engineer recorded speed of cars. So let's find that one. Traffic engineer recorded speed of cars.
Here we are. Here we are. Okay. Go fall asleep.
Okay. And we are at the 24:33. Oh, we're gonna have a nice weekend this weekend. A traffic engineer recorded. Okay. Well, let's take a look at the question. A traffic engineer recorded the speed of cars driving past their house. Yeah, we can do that one. Downhill. You got it. And Daryl's got another. So thank you, Daryl. Huge thank you, Daryl. 1,000 points, although I gave out a ton, but keep the questions rolling. So with this right here, where the speed limit is 20 miles per hour, that's the speed limit at their house. They get 100 readings. This is sample size equals 100, and was a mean of this. I think the mean it was, and the standard deviation. Using the normal model, what should the middle 95% of cars have for their speed? So what would we do with this data to find the middle 95%? Using the normal model, where would the middle 95% of cars have their speed? Mean, standard deviation, sample size. What would we do in the normal model to find the middle 95%, plus or minus 2 standard deviations? So we're literally just going to go here and go plus 2 standard deviations and minus 2 standard deviations. And so with that, we just go to our calculator and we say the mean is 23.85 plus 3.55, and then plus again. And we round to 2 decimals, and then we go back down by subtracting minus 3.55. And now we're at the mean. Now we're down 2. Now they're looking at some data they have that apparently is the real data. Now let's look at this. The middle 95 would go from what percentage to what percentage? Where would the middle 95 be on this? It'd be from what percentage to what percentage? The middle 95. Traffic engineer? Yeah. Oh, we're doing that one right here, right? I think we're doing it. The middle 95 would be between what percentage and what percentage here? The middle 95 would be between what percentage and what percentage? Oh, is it a little different? That might be a different one. The middle 95 would be between what percentage and what percentage? The middle 95 would be between what percent and what percent? Who knows? The middle 95. So if you have, well, think about this. You got it. Think about this. If 95% is in the middle, then where is this spot in terms of percent on the curve, and where is this one? This would mean you're at the what percentage down there, and the upper one would mean you're at what percentage. Because here's a hint. 2.5 is above here. 2.5 is below here, and that's a huge hint. So then middle 95 is between what and what percentile? The middle 95 is between what and what percentile? Good guess, not 16, good guess. The middle 95 is between what and what percentile on the curve? Because percentile is area below. So that should be a good one right there. We should be able to know that one. Oh, the 2.5, you got it. The 2.5 and the what's the other percentile? What's the other percentile here? Where's the top 2.5 at the what percentile? So now the other one is at the what percentile, which is the area below. The other one is at the what percentile? 97.5. This is the actual data. Once again, this is your actual data, which you actually see with the real numbers. We said, well, what does the normal curve say we should see? Now we're looking at what we actually see. So the answers are 17.04 and 30.767. So 17.04 and 30.4. I think I'm gonna double check. Just double check. There we go. There we go. I think we got it. Okay, which are, they're pretty close. Close to. Since the distribution appears slightly normal, we should not be surprised. Should be correct. They should show us the shape of it. But if the data is pretty normal, then the expected values on what we should see according to the empirical rule would line up with the actual data. That's what they're getting at here, is if you would expect to see this given the normal distribution, and then you do see it in the data, then you'd get this right here. Good question, good question. I think we'll do data analytics towards the end. Thank you so much, everyone, for being here. I think we have two more we'll do Yans, and then we'll do the Glassdoor one. And drop some more questions. We'll have time for data analytics. I think these are both Chapter 5, Part 2, Alpine skiing. We're going to do Alpine skiing right here. Alpine downhill skiing. Okay. Getting these ready. How's everyone? Is everyone doing something cool for the weekend? Oh, there was free lunch. I might have signed up for it. Sorry if I did. There was free lunch. There's free breakfast. I wish every week was Faculty Appreciation Week. That'd be so cool. Just get free coffee every day. They're very nice. And thank you, UT, and thank you, Haslam, and everyone. I feel greatly appreciated. Very often, I do. Okay. And appreciation to all the great teachers here at UT, working very hard. Here we are with the Downhill Alpine Skiing Challenge. This one's a little bit similar. I'm taking the timestamp right now. Just got a farm, so 4 holes. Oh, that's so cool. Congrats on your family for getting the farm. If you want to say how many acres, feel free to say your call. But you're welcome, Madison. Good, that helped out right there. This one is actually very similar to the last one we did because you look at what you see in the data and see if it matches up with the normal. So the first question we have right here is it gives us the mean, it gives us the standard deviation, and then we use the applet to see if this is what percent we'd expect greater than this time. So we're going to go ahead and take this information, drop it into the applet. The applet is no longer pinned. 11 acres, woo! A lot of land right there. Good stuff. Good exercise, man. It'd be great to get some cardio, go out to a farm. I'm not going to do it, though. It'd be really good cardio, like lifting and moving things and taking down things. And yeah, be good cardio. Okay. So we're going to go and use this right here. And we're going to go above. Please note exactly. Daryl's like, you good? I'm good. We're going to go above 108.17. Back in the day, I used to do more things like that. And so please note, this is the mean. This is the standard deviation. We are finding the percent. That's what p-value is being used for right here, above using x. And the answer is this. You can round to whatever decimals are needed by going to the round up there. It has to be entered in exactly like this, using the mean, the standard deviation, also using the observation, and then finding the percentage. And we were doing it to 1%, so this needs to be times by 100. It'll be 5.4. That is what is expected given the normal. Now they say, what percent do you see in the data? So there are 53 times, and we're asking above 108.17. How many times are above 108.17? Out of the 53, how many times are above? Out of the 53, how many times are above 108.17? Does anyone see it? There's the answer. Out of the 53, how many times are above 108.17? Out of the 53, how many times are above 108.17? Oh, there's the answer. 5, Yan, great job right there. 5 times are above. So what percent is that? How would we figure out the percent of times above? You're right there, you got it. How do we figure out the percent of times above? Because it says what percent from the actual data. We're looking at the actual data. The actual data shows 5 out of the 50. How do we figure out the percent out of the 53? Forster measured? Yeah. If we don't get to it, it is in yesterday's video. So Alyssa, thank you for asking. Boom. Zachariah on fire right there. You got it, Zachariah. Yes, 5 divided by 53. There we are. Times by 100. Round to 1 decimal. Drop it in. Do these two percentages agree? It's a little subjective, but kind of. The percentages. Why would these 2%? Oh, why would they not agree? They would not agree if the data is not unimodal symmetric. If the percentages are off, it's because the data is not normal, which the normal has 2 characteristics, unimodal symmetric. Now, this you could put it into jump, but the answers agree. So if the answers are agreeing pretty good, which of these distributions do you think is most likely? Our answers are pretty close. So do you think answer A, B, C, or D is what we are seeing? Which of those do you think we're seeing if our answers are kind of close? Close enough. Normal enough. Do you think we're looking at an A, B, C, D, or D distribution? If it's like they're kind of close, they're close enough. Which one of those do you think we're looking at? If the answers agree, it's probably because our data looks what? Our answers were pretty close and we used the normal technique, so the data probably looks what? The empirical rule requires that your data be normal. So what do you think we're looking at right here for this one? Our data probably looks what? What do you think? Our data probably looks... Do you think A, B, C, or D? Remember, the percentages agreed, and we used the normal techniques. Let's see if anyone knows. Give it a second more. B, Zachariah, you got it. Yeah. And with that, on 30,000 points right there, if I look at the data, I should probably see a lot of answers close to what? If I look at the data, I should see a lot of answers close to what value? If I go look at the data, a lot of the answers, a lot of the numbers should be very close to or around what? A lot of the observations should be close to what? 106. Let's go look at the data. Is there a lot of 106s? Ooh, we might not have that. Ooh, I was wrong. I'm going to tell you 5,000 points. I'm going a little crazy on the points. I was wrong. A lot of the answers aren't at 106. A lot of the answers are where? Brian was wrong. I'm glad we looked at the data. Maybe the percentages don't agree as perfectly as I thought. A lot of the answers are closer to what? A lot of the answers are around what? A lot of the answers are in the whats right now. Correct me right here. We were wrong. We're looking at the data now. A lot of the answers are in the whats. I don't know about 105s. There's 105s. We got a bigger region than 105s. That's 105s. I see a bigger region than 105s. I see a bigger region than the 105s. 105 is beat out by another region. 103s, 102s. This area. Do you see how there's a ton of 102s? That's going to create a peak at 102. Does that logically make sense to you? there's less 105s. Whoops. And Daryl, yeah, 101s, and that could be down there. There's less 105s up here. There's more 101, 102s. So when we look at the data, the answer is very clearly A, B, C, or D now. Very clearly, the answer is A, B, C, or D. Very clearly, the answer is A, B, C, or D. Remember, we said there's a lot of 101s, 102s. A, B, C, or D. I was wrong. Brian went a wrong path. They did change this question years ago. What do you think? There's a lot of 101, 102s. It is D. If they agreed more, it'd probably be closer to B. But we looked at the data. What can be seen from the histogram? Monster Man. Okay, this answer, I want a quick answer to it. A, B, C, or D. What's going on with this data right here? You know the Monster Man. A, B, C, or D. What is the answer? A, B, C, or D. Don't worry about being wrong. Give it a shot. D. It is right skew. Right to the high, left to low. Whatever way the Monster Man's tail goes. Make sure to draw your Monster Man. Make sure to say, hello, Monster Man. Good to see you. You have a right skew tail. Very cute. Right to the high, left to low. Whatever way the Monster Man's tail goes. Right to the high, left to low. Good job. Good question. I do like that one. They changed it years ago. It used to have you actually say if the percentages agreed, but I guess I thought that was a little too subjective. The Glassdoor one. We did do data analytics yesterday. Also, I went into detail. So if we don't do that today, because I will do in-person office hours here in a little bit, if we don't do the data analytics today, please check out yesterday's office hours where we also do a lot of Chapter 5 Part 1. If you're stuck on anything, let me know. These are tougher quizzes. Okay, there's some of my favorite, though. Okay. Drop a few more in the chat. I think we're kind of... Do we have other ones listed after this? Drop a few more. I try to grab them and put them in my notes so we can do them here next. Okay. Here we are with the next question. Let's look at the histogram. What are your thoughts on this? Give me some thoughts. Cutoff value? Yeah, tell me the start of it a little more, Zachariah, and I'll find it here next. We'll do that one next. Tell me a little bit more on the cutoff value. I'll try to do different things. And then tell me your thoughts on this histogram. I mean, I'm telling you my thoughts right now. Ooh, whoops. Ooh. What's your thoughts? Man, I wish all data looked like this. Thoughts on it? Any observations? Looking at that? Any just premonitions? What do you think? Anything? Bueller? What do you think? It's like I'm trying to say. IQ? Yeah, we'll do that one. You got it. Gonna mark it. Looks pretty darn normal to me too. Yeah, it looks pretty normal. Great answer, Zachariah, right there. Yeah, it looks pretty normal. Which means we can use the empirical rule. We can use the 68, 95, 99.7 rule. You can only use that when data is normal. Unimodal symmetric. Okay, let's view the histogram part C. Middle 95%. I think they logged the data or something like that. It's still normal. It's normal either which way. It actually got more normal. According to the normal model, what percent of CEOs would you expect to make more than 2 standard deviations above the mean? So if you go out 2 standard deviations, what percent of area is above 2 standard deviations? Does anyone know? What percent of area is above 2 standard deviations? 0, 1, 2. These numbers don't really matter. We're doing z-scores right now. If you go above 2, then what is the area above 2, according to the normal model? What is the area above 2, which is this? Looking for that answer right there, that arrow. Does anyone know? Here's some hints. That's a hint. It's not the answer. You want to find this right here and then cut it in half. So what's the answer? You know you've done it properly if you get 100% when you draw across the curve. So this is down at -2. I might not have drawn it perfectly, but it's close enough. And it would be 2.5% because that's what we're looking for, the yellow shaded area. It should be 2.5%. Is that percentage appropriate? When would it be appropriate to do this? When the data looks what? When the data looks what? When would it be appropriate? When the data looks what? Is it appropriate to do this? When data looks normal, unimodal symmetric. So here's the new data. Do you think we can use the normal curve? With the new data, do you think we can use the normal curve? Yes, or just say yes or no. Don't worry about their questions. Just yes or no. Do you think we can use the normal curve on this? Do you think I'd be like, let me see if it's a good fit, like goodness a fit, and a little kurtosis. Is me. Yeah, I think so too. It looks mostly unimodal symmetric, a little more peakedness than usual. Yep, unimodal symmetric. There you go. That's got it. That's that question. So it's just, use the normal technique on normal data and understanding the empirical rule. Here is the IQ. This is a different one. We did one just like that earlier. So if you're wondering about that one's also some IQ test. No, they don't want to talk about IQ here, apparently. We could have basically done all these. We've done a lot of them. The NFL one's good. It's a quick one, too. Did I miss it? It's IQ tests are standardized to a normal. Am I missing it?
Oh, here it is. Oh, it's some. Oh, that's why I missed it. Some IQ test.
Okay. Fall asleep. Need that third cup of coffee. That's it. Yeah. Okay. Thank you for being here. Remember, just swing by these office hours anytime. I'll try to be on time. It's a busy semester. Well, who doesn't have a busy semester? Who doesn't? Be nice. Be slow. Be boring. What am I saying? Okay, here we go. So with this, some IQ tests are standardized to the normal curve. What's that number? What's that? What is this 119? What's the deal with those? The mean and the standard deviation. Nice job, Zachariah, right there. So the mean is this. The standard deviation is this. What you need to do, grab your scratch sheet of paper if you don't have it, is you need to draw your normal curve. I promise you, you will learn a lot more drawing these out like I do. And you put 100 here, and you put going up by 19, and then you go to 138. You go up 3 standard deviations. There are IQs beyond this. Not mine. I don't know, maybe. No, not. No, that's very, 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 very high. Extremely high. So there we go. And with this right here, it asked us about the top 15%. Now here's the thing, you can kind of guess this. Watch as I answer some of these questions. Let's see how I do. So the highest 15%, round to 1 decimal. I'm going to say 120.1. The lowest 21 decimal. I gotta learn what 1 decimal is. The lowest 25%. So that's going to be about lowest 25%. So that's going to be 80. Oh, I can almost do it. Come on, brain. Come on, brain. It's going to be 87.2. The cutoff for the middle 60%, it's probably going to be about 83 to 117. How many did we get right? That's using no technology. That's all guesses. So here's how to solve it. You need to go to the what? You need to go to the what? You need to go to the apps. When you go to the apps right here, you're trying to find the value. You're trying to find the value. To find the value right here, you need to say, find X using the percentage. Find X using, you're finding X using a percentage. We're going to put in the mean of 100 and the standard deviation of 19. The first question was the highest 15%, which is actually the what percentile. The highest 15% is the what percentile. The highest 15% is the what percentile. Was off by a little bit on that one. The highest 15% is the what percentile. So I got this one right. I got the last one wrong. The highest 15% is the what percentile. The highest 15% is the what percentile. So the highest 15% is also known as the what percentile. It's a good thing to know. The top 15% is at the what percentile. Because you could do the top 15%, but that's the what percentile. Good question. The top 15% is the what percentile? The 85th. Because if 85%, 85th. Because think about this, it's at the 85th. The top 15% is the 85th percentile. Because if 85% of data is below here, does this make sense conceptually? If 85% of data is below this point, 15% is above. So it's the subtracting from 100%. Daryl and Zachariah, do you see that? This is the 85th percentile, which is the same spot on the curve where the top 15% is at. It's the same exact spot. It's just depending on how you talk about the 85th percentile or you talk about the top 15%. You could also do some weirdness right here where you do the outer 30%. And if you do the outer 30%, you will get the answer here again. That's because there's 15% here and 15% here. When you get a picture on the test, what you want to do is go to your test question and immediately start drawing on it. Because if 30% is shaded, then that puts 15% here, 15% here. This is the 15th percentile. This is the 85th percentile. Does that make sense? Because this is the middle 70% in the middle. Does anyone follow what I've done here by drawing on it? NFL data? Yeah, Daryl. Mainly Chapter 5, Part 2 here. Good stuff. So you want to do this. And with the applet, you can pretty much get all of these questions. Because now, if we want to find the middle 60%, we just go to middle 60, or rather, middle 40. 84 and 116. Dang it. I was so close. I was lagging. Almost on the right. Alert. Oh, that's the other homework. Whoops. 84 and 116. Notice the symmetry. Also notice that when you solve this, right here, the outer 40 would have how much in the middle? The outer 40 would have how much in the middle? The outer 40 has how much in the middle? Because if 40% is on the outside, it'd have 60% in the middle, but you could just go here and just top between and get the answers. Does that make sense? Or you could go the long way and say, well, it would have 20% below, and you could do the bottom and the top like this. There's so many ways to do it. You just have to know what you're looking at on the curve. So you can just go for doing the inner 60 or whatever you want. You can just straight solve the answer, but you should know what you're looking at. Like, that's the bottom 20%, the 20th percentile. This is the top 20%, also known as the 80th percentile. This is the inner 20%, which would be the 40th percentile to the 60th percentile on the curve. Does that make sense? Like, make sure you know what you're looking at, because it can get tricky on the test, like looking at different things. NFL data. This one's really good. I like it a lot. Okay. Thank you, everyone, so much.
Man, busy week. It's pretty much over. Oh, man.
Okay. NFL data for the 2019 season report. 2019, only 6 years ago. We had 508 receivers. The mean was this. The standard deviation was this. Complete the information below. Let's look at how the data looks. Let's take a look. And oh, how do you feel? Oh my gosh. How do you feel about this? How do you feel? What's your thoughts? Just talk to me. How you feeling about this data? Let's do a little goodness of fit. Let's do a fit check on it. Toast. Because when we try to fit that normal, we say normal curve, not happening. Normal curve's not happening today. If we did a normal probability plot, it would not follow the line. That's right skew, so it's going to look like this. It would look like that. So the normal curve does not fit. Goodness fit test fails by just doing it conceptually. The drawn out normal probability plot does not follow the straight line, does not look normal via histogram. Also, the 3 ways to check normality: normal probability plot, look at the histogram, and goodness fit test. Make sure to know what those 3 are. Check out lecture review. So we're definitely not dealing with the normal, but if it was the normal, what percent of receivers would get more than 2 standard deviations above the mean? If it was normal, what percent of receivers would get more than 2 standard deviations above the mean? If it was normal. If it was normal data, what percent of receivers would get more than 2 standard deviations above the mean? So we just draw this curve out, go 2 standard deviations up, go here and above. If it was normal, boom, Daryl's on fire right there. There you go. The reason is 95% in the middle between positive and -2. And there you go. And so that'd be 2.5 here because 2.5 on either side. So there you go. It'd be 2.5. And for these data, what does that mean? Well, we're asking what percent of receivers would gain more than 2.5 standard deviations above the mean. So what do we have to do? We have to find out how many receivers this would be. Well, what do we do? 2.5% of receivers out of 508. We type the number right. And there we are. That's 2.5. And we round to the nearest whole number, so 13. And then we need to go 2 standard deviations up. And when we go 2 standard deviations up, we go 312.357 plus 253.756. And there it is, 2 standard deviations above, and we drop in. And what's the problem with the data? A, B, C, or D? You know Monster Man. You know the Monster Man. Do you know the Monster Man? A, B, C, or D? Might have to sing that really quick, but this one, please no one get this wrong. This is reinforced so much in the learning. A, B, C, or D. You only need to see that much. The answer should be apparent now. A, B, C, or D. I wish everything was as easy to learn as Monster Man. A, B, C, or D. B. There you go. I say it with confidence. Oh, what? What did we do wrong? Okay, what do we do? We didn't get anything wrong today until this. 1 decimal place. Okay, 2.5. That's wrong right here. This is a wrong number. Okay, so that's wrong. Oh my gosh. So it's 0.25% of 508. Okay. And then did we do the next one? Oh, the mean. I totally did mean standard deviation backwards. The mean plus standard deviation is this one. Okay, there we go. I used the wrong mean and standard deviation. There we go. It'll be right. Yeah. Make sure you use the mean plus 2 standard deviations, just to write that visually here. The answer was the mean, not the standard deviation. The mean plus 2 standard deviations. So mathematically, it is the mean plus 2 standard deviations, where the mean is this, and the standard deviations are this right here. There we go. Awesome. I might go grab a little bit of food here. I need a snack. With that, really great work, everybody. We did a lot. Chapter 5, Part 2. Now, we do have Chapter 5, Part 1 and the data analytics. Let me see, because a lot of people might be starting it tonight. Did I put it in the assignment? The data analytics help. Let me do visual. I try to add these to the visualizations. I should have put it in there. Bavariate. The 14th is due tomorrow. Oh, it's not in here. Okay. Tell me about that visualization playlist. No, visual. I always forget the quick word for it. Visualization playlist. Okay, here we go. And bookmark this playlist if you want. Very good playlist. Okay. One person watching. What? Okay, there we go. Put these in like highlight. No. Sure. There we go. At the start, that looks horrible. Might just be better if we bold it. Not do that. There we go. There we go. Okay, I think that's good enough. Okay, blank screen. Gonna grab a snack. We're gonna head out. Till then, bye for now, everyone. Bye.